evening. Well, we've seen the last of summer, such as it was, and we're now into autumn. And that means we've seen the last of the main summer stars. They're still there, but they're not so good as they were. In their place, we have the constellations of autumn, which are not so brilliant, but are full of interest. And this evening, I want to concentrate upon two of them, Pegasus, the flying horse, and Andromeda, the princess. Pegasus first, it's easy to recognise, high up in the north, and its four main stars make up a square, and Andromeda leads away from the square in a line. And the stars on the square are not all alike. Bottom right, Markab, magnitude 2.5, bluish white. Bottom left, Algonib, magnitude 3, also bluish white. And then top right, Skeet or Beta Pegasi, which is orange. It's a giant star, about 9,000 times more luminous than the Sun, and 200 light years away. And it is slightly variable, sometimes slightly brighter than the Markab, sometimes slightly fainter. And finally, top left, Alpheratz, magnitude 2. And there's a rather minor mystery here. Obviously, it belongs to the Pegasus pattern, but for some reason I've never been able to follow. The International Astronomical Union has taken it out of Pegasus and given it a free transfer into Andromeda. And Andromeda itself has no definite pattern. It leads away from the square. So Delta Pegasi became Alpha Andromedae. Well, of course, these two constellations, Pegasus and Andromeda, there are many legends attached to them. So let's go now down to the beach where Paul Abel is ready to tell us about their mythology.
Many different cultures from around the world looked at the autumn sky and put their own myths and legends there. The most familiar story is Greek. In classical drawings, Andromeda is in much distress, and so she should be. The poor virgin princess has been sacrificed by her parents, chained to the rocks, awaiting a ravaging sea monster. The line of stars which points to the Andromeda galaxy make up her waist, and the star Alpheratz, her mouth. In my drawing of Andromeda, she is mournfully awaiting her rescuer, the noble and brave Perseus. The Hindus had a much more down-to-earth view of this part of the sky. Called Uttara Bhadrapada, this region is represented as a bed, or a funeral cot, with the square of Pegasus being its legs. The Hindus believed that this region symbolised structure and stability, and when in the sky, it was said to be a good time to build houses or found communities. But back to the gory Greeks and tales of Perseus.
Well, we've been looking at the myths of Andromeda. Let's move over now to Pegasus. And the creation of Pegasus itself involves that most terrible, most feared monster, the Gorgon Medusa. It was said that Medusa stood enormously tall and her hair was a writhing sea of serpents, and a single glance at her eyes could turn a man to stone. Now, Perseus, the great warrior, was not fearful of her at all, and by using his polished shield he could see where she was, and in one go decapitated the monster. And from her body sprang Pegasus, the beautiful winged white horse, who then flew away to Mount Helicon and was used by Zeus, king of the gods, on many missions, and eventually, as a reward for all his work, placed Pegasus in the sky. Moving on from Greek mythology, we come to the Chinese, and I think it's fair to say the Chinese were some of the most creative constellation makers on the planet. For them, the region represents not a flying horse, but one of the four symbols. Each symbol represents a direction and a season, and the Pegasus region represented the great tortoise of the north and the oncoming of winter. In constellation charts at the time, you'll see a black tortoise with a serpent coiled around it, for the simple reason they believed that both the tortoise and the serpent created the Earth.
The Chinese may have been the most imaginative, but when we see the four stars of the square, it is the Greek horse Pegasus which springs to mind. But in the autumn night sky, you'll find he's upside down, on his back. With some of his astronomical delights, Pete Lawrence with Tom Curse.
So, Tom, you've travelled down from London.
I have.
Now, You've got quite a lot of light pollution in London, of course, so I should imagine the Square of Pegasus is quite a tricky thing to pick out. But you can actually use it as a test for sky clarity.
That's right. So inside the Square of Pegasus there are stars. A little bit difficult to see when you step out, but as you get adjusted to the dark, you're able to see a few and determine what the sky is like by the number of stars that you can see.
Okay.
So in London, where I am...
How many can you see there?
We can see precisely 0 stars
in
the Square of Pegasus. So our skies are not very good, but you would fare slightly better here in Selsey.
Well, I think the average in Selsey is probably about 7, between 4 and 7 stars that you can see inside the square. So that's not bad, really. If you're in a really good site with no light pollution around you at all, very dark, clear skies, do you know you can actually see up to about 30?
30.
Well, that's amazing. Well, the square is up there at the moment.
Okay.
Because if you look at it on a chart, it doesn't actually look that impressive, does it?
It looks a bit smaller. That's what I find. When it's projected on a chart, it looks like it's a small, compact square. But on the sky, it's actually a lot bigger and sparser and not quite as bright as you expect.
It is a very sort of sparse area, isn't it? And the way to sort of describe the size of it is to use your fist and hold it up at arm's length, and a side of the square is about 1.5 times the width of your fist.
That's about 15 degrees.
That's right.
As your fist is about 10 degrees when you hold it up at arm's length.
And the square represents the torso of the flying horse.
It does.
And from the UK, he's quite difficult to pick out because he's upside down.
Exactly, and he's sort of flying out of Andromeda's head with no hind legs at all, so a slightly unusual
It is an unusual thing, but his head is picked out by a nice triangle of stars to the lower right of the main square.
Quite right.
Now, the star right at the extreme right of that is called Enif.
And that's the brightest star.
That's the brightest star in Pegasus, and it's the nose of the horse.
It is, so it actually Enif comes from the Arabic word for nose.
Okay.
So we think of it as the horse's snout, and Enif itself is actually a very interesting star. It's not just the brightest star in Pegasus, but it's also what we call an optical double.
Now, there's a special property of these two, which is actually quite strange. I'll let you describe that.
Well, John Herschel discovered it. We've come to know it as the pendulum star. And the reason for this is that if you look at it through your telescope and you draw a line between the two stars, so here's your line.
Right.
You tap the telescope so that it wobbles at a right angle
to that line, yeah.
What you notice is that the bright star move quite quickly,
as you'd expect.
As you'd expect. The fainter star, though, it moves slower. It lags behind.
Oh, okay.
So it looks like it's swinging from a piece of elastic.
Out of phase with the main bright star.
Out of phase with
That's
the
amazing.
primary.
I've never seen that, actually. I'm going to have a look at that next.
It's really quite a striking illusion, and John Herschel was the first to explain it as well. He said that, quite rightly, that the fainter star is so faint that it actually takes longer for your eye to update the picture as you see it.
That's fascinating, isn't it? So that's known as the pendulum star.
It is.
OK. So we've got Enif, which is the nose, and if we come back and go down a bit, so we come back to the left and go down a bit, then we come to a star which marks the top of the horse's head, remembering he's upside down.
Exactly.
And that's called Baham, or
Baham.
Baham, if you like. If you go from Baham through Enif and you extend the line by half as much again, you come to a rather amazing object, which you describe as looking like the carrot.
Not literally, it doesn't look like a carrot.
OK.
It's in front of the horse's nose. So if we imagine in front of Pegasus's nose, which is Enif, there is an object there which is very tantalising, not just to the horse but to us as well, and that is one of the most spectacular globular clusters on the whole sky, M15 or Messier 15.
And that is a real beauty.
It's actually one of the oldest and densest known as well.
Right, OK. A globular cluster, of course, is a vast collection of stars which are all bound together gravitationally. And in this case, there's about 100,000 stars, all compressed into quite a small part of space.
Yeah, it's no more than 200 light years wide.
OK.
And we know that it must be, therefore, over 30,000 light years away. That's outside of the galaxy's disk.
Because all the globular clusters we see are in a halo around the core of our galaxy.
Exactly.
Now, M15 isn't actually that difficult to find or see, is it?
No, you can see it with the unaided eye if you have exceptionally good skies. It's very easy to see in binoculars because it looks distinctly non-stellar.
Yeah.
It doesn't look like a star, it's a fuzzy blob, and if you use a small telescope that's even more apparent. But with a large telescope, well,
it's an amazing sight. It
start to see the individual stars.
It always reminds me of a glowing spider's nest. You know, you get that sort of collection of web in the centre of it. That's what they always remind me of.
That's a very terrifying image, Pete.
Pegasus will be forever immortalised for being home to 51 Pegasi, the first star found to have an exoplanet in orbit around it. Earlier on, Italian astronomer Dr. Giovanna Tonetti came to Selsey to see Patrick and Chris North. She studies these worlds around other stars, and so far, most of them are gas giants. We know of more than 650 exoplanets out there, but 51 Peg b will always be the first.
What's it like?
What we know about the sort of class of planets like 51 Peg is that they are presumably very similar to our own Jupiter, so gas giant planet, mainly made of hydrogen. But these hot Jupiters are orbiting very, very close to the star, like 51 Peg b. Sometimes they have a few day or even less than 1 day annual period, and it means they can reach temperature that are over maybe the 1,000 or 2,000 degrees Celsius. So clearly are a bit like hells.
Not so long ago, we had no definite proof of any planets outside our solar system.
It's astonishing how quickly this field is moving. I mean, 16 years ago we found the first, and now we know hundreds of these things. And that's because of all the different experiments and satellites and telescopes we've got detecting them. I mean, we've got telescopes looking for the tiny wobble of the star as the planets go around them. So, I mean, our own solar system does that. The solar system doesn't rotate around the sun, it rotates around the centre of mass of the solar system, which is roughly near the edge of the sun. So if you were to look at the sun from afar, you would see it wobbling, mainly because of Jupiter.
Yeah.
And we see that in these other solar systems, and that's the main way of detecting these planets.
But all these planets we found are much more like our Jupiter than like the Earth. Is that a surprise?
Well, clearly the first planets discovered were more similar to our own Jupiter, just because it was easier from, from an observational point of view, look at big objects. But the technique have been really refined during the past years and even months, and now we are approaching very fast and very rapidly the mass of the Earth. And in fact, today the lightest planet is about 2 or 3 Earth masses, so extremely rapidly we are approaching something very close to our own planet.
Do you think there are many planets in our galaxy that are similar to the Earth?
Well, I believe so. I believe so because the statistics is telling us that this rocky type of planet seems to be very common, and so we are expecting a lot of Earths similar to our own. But I clearly want to see the experiments, and I am particularly quite interested in trying to understand what is the composition of this planet, if they're habitable or not. And so,
what about the atmospheres?
for the moment we don't know yet, but we have candidates of planets we would like to explore and to observe, to know the composition of the atmosphere and to know whether they can host life or not.
So if you had to place a bet, how long would you say it'll be before we find an Earth-like planet?
Well, given that the pace of discovery we're seeing with Kepler and radio velocity, Doppler sort of measurement from the ground, I would say 1 year time. 1 year? Yeah.
Wow.
Well, we are so close.
Yeah.
Even so, I might see it then. Good. Thank you both very much. I'm delighted to see you going back on the programme. Come back soon. Thank you very much indeed. What about the stars in Andromeda? I say the main ones lead off in a line from the square of Pegasus, beginning, of course, with Alpheratz. The second bright star, about the same bright brilliancy, is Beta Andromedae, or Mirach, which is definitely orange. And the third is Gamma, or Almach, which telescopically is a rather lovely double star. But of course, the real glory here lies in the great spiral M31, the nearest really big spiral to our own. You can just see it with the naked eye, use Mirach as a guide. Telescopically, well, it's placed at a bad angle to us, but you can see it really is something very unusual indeed. Over now to Pete and Paul.
So, Paul, M31, the Andromeda Galaxy, this is a real showpiece object in the night sky, in the constellation of Andromeda.
Yeah, it's a wonderful thing. Do you know, Pete, for the first time ever, when we were in County Wicklow in Ireland a couple of weeks ago, I saw it with the naked eye. It was really, really dark sky. I really couldn't believe it. You can see it with the naked eye. It's so impressive.
It is. Well, I see it quite frequently down here because
you're all spoilt.
I'm spoilt because I haven't got much light pollution. If you're in a city with lots of light pollution, it does actually cut out M31.
It does, yes, it does.
OK, well, I suppose what we'd better to start with is how to locate M31.
Quite an easy one to find, isn't it?
Well, the easiest way I do it is by taking the top of the Great Square of Pegasus, the two stars at the top of the Great Square of Pegasus, and extending the one from the top right through the top left for the same distance on again, but bending up a bit until you come to another star which is about the same brightness.
Right.
And that's Beta Andromedae.
Yeah.
And then you do a right angle turn, you go up until you see one which is slightly fainter, which is Mu Andromedae. Keep going a little bit further, there's Nu Andromedae, and right next to that, that's the Andromeda Galaxy. This is a galaxy of several 100 billion stars.
And quite a bit larger than our own. They're very similar.
Now, I'm glad you mentioned that both the Milky Way galaxy and M31 are of similar size, because I have a demonstration
I thought you meant some of the cheap Pete Lawrence demonstrations. Oh, OK, this is good.
So who do you want to be? Do you want to be?
I'm going to be Andromeda.
Okay, you're the Andromeda
I'll be
Galaxy.
the Andromeda
okay.
Galaxy,
So
yeah.
from the Milky Way galaxy, which is where I am here, you need to be tilted by about 13 to 15 degrees.
Is that enough?
That's a bit too much, bit flatter than that, actually.
Sake. Okay.
There we go, like that.
All right, OK, that's...
Now, I need to be tilted to you by about 60 degrees, so
Right.
about like that.
OK.
And to create a scale model, we have to be about 3 metres apart. You can put them back over here. Now, that represents more or less the scale of what we're talking about
And
here.
that you could see that distance, that enormous cosmological distance with the naked eye, is quite fantastic.
It's amazing. It's about 2.5 million light years away.
Absolutely. Of course, over time, these two galaxies are coming
heading
together.
towards each other. If we simulate a 3 to 4 billion year time period, they will come together. Now, could be quite a terrifying thought, of course, but of course the huge distances between all the stars means that there probably won't be any collisions at all.
But it will be quite a spectacular view.
Probably won't be around when that happens.
I bet you will be, and I bet it'll be cloudy.
OK, well, now if we look at M31, you can see the core, but you can also pick out two other fuzzy patches either side of it. Now, those are satellite galaxies of M31.
They are gravitationally connected to.
They are indeed. They actually go around, they orbit mutually around M31. But in total, there are about 19 satellite galaxies to M31, which is an awful lot.
There really is remarkable. Just goes to show the enormous gravitational power of the thing. It's an enormous thing.
It's just an amazing object.
M31, our nearest large galaxy and close enough for us to study, telling us more about our universe.
We get a great deal of science out of M31. For example, the Cepheid variables and its distance.
Yes, these are particular types of variable stars. Now, we know of lots of them in our galaxy, and Cepheid variables are important to astronomy because if you know how fast they're pulsating, how fast their brightness varies, you can link that to how luminous they are intrinsically in their own right. And when you know how luminous they should be, how much light they're actually giving out, you can compare that with how bright they look in the sky, and that gives you an estimate of how far away they are. And this was done in the 1920s by Edwin Hubble, the famous astronomer after whom the Hubble Space Telescope is named. And he looked at some of the stars we could see in what was then called the Great Andromeda Nebula. And he discovered it was incredibly distant, way, way outside the bounds of our own galaxy. And this was in the 1920s, and the first proof we had that there were galaxies outside our own.
Up to that time, there'd been a tremendous argument about it. The theory that these galaxies might be island universes. I've got a book up there by Agnes Clark, a famous 19th century historian, describing the island universe theory as a half-forgotten speculation.
It's one of the things that fascinates me is that it's only, I mean, what is it? It's 80 years ago that we discovered these things are outside our own galaxy. So how much has our understanding of the universe and its size expanded enormously since then? It's quite staggering.
Way back in 1885, what seemed to be a nova flared up in M31. It was far brighter than ordinary nova, and we now know that it was a supernova.
Yes, these are enormous explosions that are created when a star, several times the mass of the Sun at least, explodes at the end of its life and dies. And this was discovered in M31, which gives us an excellent way of studying them in detail because it's not too far away. But supernovae are more important on a cosmological scale as well for looking at distances to other galaxies.
What about the other galaxies close to M31? There's M33, the triangulum spiral, and that I like. It's much smaller than M31, but it's a much better place. It really is a nice spiral.
M33 is not far from M31 in the sky. It's in the constellation of Triangulum. It's a little bit further away. It's not quite as brilliant to look at, but you're right. It's face on almost. It's a much better angle. It's a bit smaller than M31.
Oh, quite a bit smaller.
And we think it could be interacting with or it could have interacted with M31. It could be in orbit around it. These things are quite hard to tell, quite hard to measure in detail. But that could be one explanation of why it's a bit smaller. Maybe in the long distant past, billions of years ago, it had an interaction with M31, stripped some of the stuff out of it.
Well, next time it's clear, go and have a look at these for yourself. But there are other galaxies to see, so let's go out of the garden once more and join Pete and Tom.
So, Tom, we're out here under the autumn skies, and the one thing that's noticeable by its absence is the Milky Way.
Which is, of course, the
our
galaxy
own
that
galaxy
we live in, right.
Now, the Milky Way is rotated out of the way at this time of year, so that means that we can look out at right angles to the galactic plane, and we're looking out into deep space.
And we get this fantastic clear view.
That's right, and what we can see there are other galaxies, like our own galaxy, much further away from our own galaxy.
So we're in Pegasus. Let's take a look at some of the galaxies that we can see. Where would you start?
Well, I'd probably start close to the Great Square itself, because if you go to the upper right-hand corner marked by the star Beta Pegasi, there are two fainter stars just off to the right of that, which make an equilateral triangle. There's Mu and Eta Pegasi. Mu is the bottom one, Eta one's the top one. If you draw a line between those two and carry on for the same distance again, through a small telescope, you can locate an object called NGC 7331. It's an interesting galaxy because it's often compared to appearing to what we think the Milky Way would look like if we were looking at our own Milky Way galaxy from that sort of distance. And also the core of NGC 331 rotates in an opposite direction to the spiral arms, which is rather
very
odd.
unusual. Yeah.
But you can use NGC 331 as a stepping stone to a much fainter group of galaxies, a compact group of galaxies known as Stephan's Quintet.
After Edward Stephan, who discovered them back in the 19th century, but he must have been using a pretty big telescope.
Yeah, they are pretty faint. You do need a big telescope to see them, but they are quite fascinating because you've got, surprise, surprise, 5 galaxies there, but it has been determined that one of those galaxies is actually a foreground galaxy. So it's only 4 galaxies, really, which are close together.
Right.
And those 4 galaxies, which are about 300 million light years away, are actually interacting with one another. And if you look at Stephan's Quintet with a space telescope, you see these fantastic arcs of star formation there. And quite surprisingly, a little smiley face looking back at you.
Are you going to be trying to capture this smiley face, Pete?
I think it's probably a bit too faint for me, to be honest.
You need to get yourself a space telescope.
A space telescope. But there's a much brighter galaxy in Andromeda, neighbouring Andromeda, which is actually quite impressive, isn't it?
Well, it's a beautiful one because this one is an almost perfectly edge-on spiral galaxy, and although we can't see the disk of our own galaxy at the moment, we might imagine flying out of the Milky Way and looking back, and we might see something a bit like this one, which we call another NGC 891.
And that's a beauty, isn't it? It really does look like a flat edge-on galaxy, and you see that beautiful dust lane running through it. Absolutely amazing.
If you can see it in a large telescope, it really is quite remarkable how much detail you can see. And of course, it's a very, very popular target for images as well.
Yeah, OK. Well, another galaxy which is actually quite easy to locate but very difficult to see is called, it's got a rather enigmatic and quite scary name, perhaps.
Bit spooky.
Mirac's ghost.
Right.
Now, Mirac is Beta Andromedae, so it's the star which you'd use on your way to finding the large galaxy M31, the Andromeda galaxy. So if you locate Mirac very close to it, it's about a quarter the diameter of the full moon's distance away. There is a small lenticular galaxy, which is known as NGC 404.
Now, it's very, very difficult to see, but of course, being a galaxy, it's made up of billions, tens, maybe even hundreds of billions of stars, very similar to Mirac itself.
Yeah.
It's just so much further away that it's completely outshined by this nearby star.
Well, the star itself, the glare from that star, is what makes it difficult to find Mirac's ghost. I've looked for it visually on many occasions, and I'm afraid in my logbook it says NGC 404 not found.
So much for the autumn constellations, but we have one brilliant planet there too, Jupiter. Look at it through your telescope, you see its belts, its moons, and its changing surface. It's the subject of our yearly competition to select the astrophotographer of the year, and the winner actually lives in Chelsea, and Pauline went to see him.
Well, I'm here in Selsey to meet a rather famous astronomer. Not Patrick Moore, but Damien Peach, the celebrated lunar and planetary photographer. Damien's high-resolution images of the moon and planets, most of them taken here from his garden, show that you can take extraordinary pictures from a very ordinary setting.
Damien moved to Selsey just a few years ago for the clear skies. What with Patrick and Peter around the corner, Selsey has become a bit of an astronomical hotspot. His winning shot is of Jupiter and its two moons, Ganymede and Io. You can actually see surface detail on the moons. Quite amazing.
Hello, Damien.
Hi, Paul.
How are you doing?
Yes, I'm good, thanks.
Very impressive setup you've got here.
Thank you.
Congratulations on winning Astro Photographer of the Year award.
Thank
You must
you.
be very proud. That's
Yeah, absolutely.
phenomenal picture of Jupiter, but we should tell everybody, shouldn't we? You didn't take it here, did you?
Sadly not, no. I wish I could say I did, but no, it was taken from the Caribbean island of Barbados.
Yes, you got some good seeing, didn't you?
Yes, it's a great location for it.
And how did you come to get into astronomy, in particular into planetary astronomy?
I've always had a real fascination with the planets, I think because they're dynamic objects.
They change overnight,
absolutely,
don't they? Yeah,
they're changing, they're colourful, you can see so much on them, and that's really what really attracted me to it.
I would imagine Jupiter would be a good beginner's target, would it?
It's a fantastic target. Even with a pair of binoculars, you can see a small disk and the four bright moons either side. Perhaps aside from the moon, it's one of the best objects that a beginner could look at.
What about the moons themselves? Because, I mean, I remember a time when it was thought the moons of Jupiter were dead, cold, inanimate objects.
Yeah.
And now we know that, you know, some of the most exciting objects in the solar system, and that you can get detail on them now. I think that's just remarkable.
Yeah, as camera technology has developed from film to CCD, and now we have high-speed CCD cameras, it's allowed us to really exploit the resolving power of telescopes, and it's really allowed us to kind of start recording detail on the moons, quite regularly.
And the black magic that you invoke.
Well, yeah, so always a bit of that sprinkled on it, absolutely.
And of course, Damien, Jupiter is at opposition next month.
Now is really the kind of best time to look at Jupiter, because obviously with the planets at opposition, meaning it is actually, opposite the sun in the sky, so
visible all night.
Visible all night. Step out on a clear night in October around 10 o'clock. You would not fail to notice it is literally the brightest star-like object in the sky.
And of course, opposition, a good time to start imaging or drawing, or any time that you want to make a serious start on the planet, because, as you say, it's visible all night and at its closest. So
yeah, that's right.
Let's hope that many people follow in your footsteps, Damien. Quite a few also stick with the drawings. Damien, thank you very much.
Paul.
You can see the rest of the winners by finding a link via our website, bbc.co.uk/Sky at Night. Here you will also find our newsletter, number 123, with Patrick and Pete's advice on what to look out for over the next few months. Our Flickr site is also doing well. We have 2,000 members with over 10,000 astronomical images for you to look at. Here is a recent posting from John Kemp with his Aurora over Whitstable.
Well, congratulations to all those who take part. Next month, when I come back, I'll be talking about Mars and the probe Curiosity, which is going there. Until then, good night.
Stay with us here on BBC HD. Who Do You Think You Are is coming up next.